Dear students, we will solve linear differential equation in this class by choosing integrating factor. So the process will be discussed clearly in this class. So let us start with the linear differential equations. So when the dependent variable and its derivative occur in a differential equation in the first degree only, it is called a linear differential equation. So here this equation, just look or see this equation here, the py by dx plus px y, that is equal to qx. So in this equation, the dependent variable is y, and in this case, in this equation, the dependent variable y is not only occurs in this equation but also dy by dx, that is its differentiation with respect to x, and this is the first order and degree is also 1. So this kind of equation, this form, is called the linear differential equation. That is a differential equation in which the dependent variable with its first order first degree differentiation with respect to the independent variable occurs is called the linear differential equation. So in case of linear differential equation, see here what is written: dy by dx is equal to fxy. You know that this is one the homogeneous. This is the linear simple form of the linear differential equation. Now, if fxy is has the form that is qx minus pxy, then you can write dy by dx is equal to qx minus py, or from here from here you can write dy by dx plus pxy is equal to qx. Obviously this p and this q are functions of x. So this is the standard form of the linear differential equation, and we need to solve this kind of equation. But before doing that, we have to go through some two cases. Number one is when qx is equal to 0. That means in this expression, if q is equal to 0, then this equation will turn into a homogeneous equation, and it is obviously of first order, because here only the first order differentiation of y with respect to x is carried out. And in the case of for which qx is not is equal to 0, then this type of equation is said to be a non-homogeneous equation. But it is not matter of thinking that matter of thinking that it is either homogeneous or it is non-homogeneous. So that does not matter. The process of solving of this kind of linear equations, that is, it may be a linear homogeneous equation or a non-homogeneous equation. So the process of solving will be the same. So, and in this case, this kind of equations are solved using another method that is called solving by method of integrating factor, and that will be done in next slides. So first come here method of integrating factor calculations. So the methodology is described here, discussed here. So you know that the differential equation, it may be homogeneous or non-homogeneous. First order linear equation is here, dy by dx plus pxy, that is equal to qx. You know that if q has some value, then it is non-homogeneous, and it is 0, then it is homogeneous. So that does not matter. So this is the equation of linear differential equation. Okay, now we have to choose, we choose rx is another arbitrary function of x, and that should be called the integrating factor, and the value or its application will be in special case specially. Okay, its application is special one. So the value of or the integrating factor is so special that it can be it can be used to solve this kind of equation. And so we have taken here another, or we have considered, assumed rx, another is a function of x. So it is called the integrating factor. Now multiplying this equation, that is equation number 1, both sides of this equation by rx, then what should we get? That is here rx dy by dx plus rx from here px y, then rx and qx. Okay, and now I am writing here, I am calculating the value of this term, that is d dx of rxy. That is equal to, we can easily write that rx first constant, then dy by dx plus y rx by dx. This is equation number 3. So this rx should be chosen in such a manner that d of differentiation of this should be equal to the left hand side of this equation number 2. So these Rx should be chosen in such a manner that the differentiation of Rx into y with respect to x is equal to the left hand side of this equation. So from here we can write that d dx of r into Rx into y should be here. So d dx of Rx y, carefully see here should be y. So rxy, that is the left hand side of this equation is rx dy by dx, then plus rx pxy. Okay, now just substitute the value of d dx of rxy from this equation number 3. So I have written here rx dy by dx, then y rx by dx, that is equal to rx dy by dx is here, then rx, then y, then px. Okay, so this dy by dx will cancel each other, and then we can write y drx dx, that is px rxy. These are y will cancel, and finally we obtained drx dx is equal to px rx. And from here you can write drx by rx is equal to px dx. Now integrate this equation, that will provide you log rx, that is equal to integration px dx. So from here rx is equal to e to the power p integration of px dx. And this that means that is this expression will provide you the value of rx, that is the integrating factor. So if you have given differential equation, and from here differential equation in the form of this dy by dx plus pxy, that is equal to qx, and from here you can easily find out the value of integrating factor by means of this equation rx is equal to e to the power integration px dx. So now you have to multiply equation equation number 2 by, or from equation number 2 you can we can do it in two process. Number one is equation number 2, in which manner you have obtained equation number 2. This is the equation number 2 you have obtained by multiplying this equation with by rx, or simply you have already calculated the value of rx, then you can multiply this equation by rx. So no problem is there. What you wish to, okay, what you desire to do, so no problem is there. So this is here, that is the equation number 1, that is the given equation is multiplied by the integrating factor. So this is the that equation. So from here you can write ddx of rxy from these two terms, that is equal to qx rx. Okay, so from here dd of rxy, that is equal to qx rx and dx. So from this equation you can write, just integrate this rx into y is equal to integration qx rx dx, or from here y is equal to 1 by rx integration qx rx dx. So this is the solution for y. So the factor e to the p dx, that is equal to rx, is called the integrating factor, and after multiplication of the given equation by this integrating factor, the solution will be possible, and the solution will be very easy, and you can choose, or you can opt this process to solve a homogeneous linear equation by using, or by finding out find out the value of the integrating factor. So now some examples are here. So number 1 is solve the differential equation dy by dx plus y cos x is equal to half sin x. You have to solve this equation, and you know that this equation has the form dy by dx plus p y, that is equal to qx, where your p is cos x and q is equal to half sin 2x. So this equation is comparable to the general form of linear equation, that is this dy by dx p x y, that is equal to qx, where your px is equal to cos x. So if you know, if you have the knowledge of px, then you can easily calculate or compute the value of integrating factor by using this relation. That is, the integrating factor is e to the power, you know that e to the power integration px dx, that is equal to e to the power integration cos x, that is equal to sin x, e to the power sin x. So this is the integrating factor. Now to solve this equation, you need to multiply both sides of this equation by the integrating factor. That means you have to multiply this equation by e to the power x, e to the power sin x. So that is done here. Dy by dx e to the power sin x plus y e to the power sin x, then cos x is equal to half sin 2x e to the power sin x. That is, you can write from these two terms that d dx of y e to the power sin x. It is not very difficult to understand, and that is equal to half sin 2x e to the power sin x. So now integrate both sides of this both sides of this equation. That will provide you d of y sine e to the power x, that is equal to this dx should be there. So this half, then integration sine 2x e to the power sine x dx. So from here, e to the power sin x, the left hand side will provide you e to the power sin x, that is equal to half integration e to the power sin x, then just this e to the sin x is written here, just decompose this sin 2x as 2 sin x cos x, and this dx is there, then plus 6 is the integrating constant. And from here, e to the power sin x is equal to e to the power sin x, then sin x cos x dx plus c. Now, to solve the value of the right hand side, you just substitute sin x is equal to z, and from here cos x dx should be dz, and then the right hand side will turn into the form that e to the power z, since sin x is equal to z, and then z, since you see from here that sin x is equal to z, so z is there, and cos x dx is equal to dz. So this is the form of the right hand side, the first term of the right hand side. So from there, you just consider that this equation can be or this integration can be calculated by using the method of by parts, integration by parts. So that is here done here, e to the power x z, z dz, that is equal to first z is taken as z is here, then integration of e to the power z, then minus integration of differentiation of z, that is 1, and then integration of e to the z is z is there dz. So that will give you z e to the z minus e to the z. So now substitute the value of z, that is sin x. So e to the power from the first term, this term can be written as e to the z into z minus 1. So e to the sin x minus 1. Just substitute the value of z in this expression. So this is the first term of the right hand side. So now substituting this value in this equation, you can easily understand that y e to the power sin x is equal to e to the power sin x, then sin x minus 1, just this value, plus 6 is the constant. So y is equal to sin x minus 1 plus e to the power minus sin x. This sin x is cancelled with this, and there should be e to the minus sin x. So this is the required solution. And another problem is here, dy by dx plus 3 by x y is equal to x square. And this is the second problem. We have to solve this. To solve this, just compare this equation with the general form of the linear equation, that is dy by dx plus pxy, that is qx. From here you can understand that px is equal to 3 by x. So, and qx is equal to x square. So now you need to find out the value of integrating factor. So that can be found out from this relation, that integrating factor is equal to e to the power px dx. So just substitute the value of px from here. So e to the 3 by x dx, that is e to the 3 log x. And you can write this as e to the power log x cube, that is equal to, you know that e to the power log x is equal to x. So that is equal to x cube. So integrating factor is equal to x cube. Now the time has come to multiply equation number 1, that is the given equation, by this integrating factor. So just multiply this with x cube, that is done here. So x cube, first term is dy by dx, then x cube into 3 by x y, that is here, and that is equal to x square into x cube. So from here dy by dx is equal to, and from this two term you can write d dx of y x cube, that will x to the 5, or now integrate both sides, integration of d of y x cube, that is equal to integration x to the 5 dx, and this will provide you y x cube, that is equal to 1 by 6 x to the 6 plus c, or from here y is equal to x cube by 6, and then c x to the 1 minus 3. Just just divide the right hand side by x cube. So this is the solution. And now if you choose a boundary condition or impose a boundary condition, y is equal to 1 by 6 for x is equal to 1, then you can find out, or you can understand from this equation, that is equation number 2, that y is equal to 1 by 6, that is here, and x is 1 in this case, so 1 by 6, then plus c into 1. From here c is equal to 0, so the complete solution is y is equal to x by 6 upon imposing this boundary condition, that is y equal to 1 by 6 for x is equal to 1. Now the next one is solves the differential equation dy by dx plus x dy by dx. So it is easily understandable that or it is noticeable from this expression that p is equal to x. But here is a problem, that right hand side consists of y. But in the general form of linear equation, the right hand side was exclusively a function of x, not of y. So to resolve this problem, you need to divide both sides of this equation by y. That is also done here. That is, or that can be done, or you can so you can bring this term in the left hand side. So that is done here. So second case is done here. So dy by dx, and this term is bring in the left hand side. That is, this term is brought in the left hand side. So dy by dx minus dy by so y by x, that is equal to minus of x. Or from here, so you can write easily from here that px is equal to minus 1 by x and qx is equal to minus x. So integrating factors can be calculated from this relation e to the px dx. So that is done here. That is 1 by x. And now multiply this equation, this equation, this equation by this equation by 1 by x. That is the integrating factor. That is done here. So finally we get ddx of y 1 by x, that is equal to minus 1. So just integrate this, and this will provide you y by x, that is equal to minus x plus c is a constant, or from here y is equal to minus x square plus 6. This is the required solution. Now another one is here, another problem is here. Solve the differential equation dy by dx minus y, that is equal to x y to the first. See here also, in this case, y term is so this term, the left hand side consists of y. Again, the right hand side also consists of y. So in this case, you have to divide, or you have to divide both sides of this equation by y to the 5. That is done. Dividing both sides by y to the 5, we get from the left hand side y to the minus 5 dy by dx, then minus y to the power minus 4, that is equal to x. Now just choose or let or substitute y to the minus 4 by z. So differentiate it with respect to x, that will give you minus 4 y to the power minus 5 dy by dx, that is equal to dz by dx. Or from here, minus y to from here y to the power minus 5 dy by dx is equal to minus 1 by 4 dz by dx. And now substitute these values in this equation. So left hand side will be minus, what will be the left hand side? That is, here is minus y to the power minus, sorry, it is y to the power minus 5 dy by dx. So that's value was 1 by minus 1 by 4 dz by dx, that is here. And then minus y to the 4, that is z, and that is equal to x. Or from here, dz by dx is equal to 4z, that is equal to minus 4x. This is equation number 2, and this equation is has the form of linear differential equation, where p, that is p may be a function of x or a constant. So here p is equal to only 4. So the integrating factor is e to the power 4 dx, that is e to the power 4x. Now multiply this equation, which equation? This equation number 2, by the integrating factor, that is e to the 4x. You can get that e to the power 4x, then dz by dx plus 4 e to the power 4x z, that is equal to minus 4 e to the power 4x into x. So just multiply this equation. So these two terms will provide you ddx of e to the 4x into z, that is 4 e to the power 4x minus 4 e to the power 4x x. Now from here you can write this, and after integration you can write e to the 4x into z is equal to 4 into x e to the 4x by 4, because the integration of and this term, you can find out the value of this term by using the method of integration by parts, and that is done here. And finally we get z is equal to minus x plus 1 by 4 plus c e to the power minus 4x. And now substitute the value of z. What was the value of z? Z was here, z was y to the power minus 4. So that is substituted here. Z y to the minus 4, then minus x plus 1 by 4 plus c to the minus 4. This is the required solution. Now another problem is here, y cube dy by dx plus y to the 4 by x is equal to x. So this is a linear equation. So here just you but a linear equation, but here y cube is multiplied here. So in this case, it will be fruitful if you replace y to the 4 by z or substitute y to the 4 by z. So that is done here. So y to the 4 is equal to z, and from here you can calculate that y cube is equal to y cube into dy by dz is equal to 1 by 4 dz by dx, and substitute these values in this expression. So this will provide you 1 by 4 dz by dx, and then plus z by x is equal to x, and the process will be same that of used in the previous solution, that is in this solution number 4. So just do it and find out first the integrating factor, that is here, because you know that p is equal to 4 by x. So that is x to the 4, and multiply this equation by this, so that is done here. And after that you just simplify or integrate that, and finally that will provide you z is equal to 2 by 3 x squared, then plus c x to the minus 4. And from here y is equal to, you know that y is z was y to the power 4. Just substitute the value of z, that is y to the 4, that is this, or y is equal to this entire term to the power 1 by 4. So this is the solution. Just go through this. And now the another problem is solve the differential equation dy by dx plus log x to the power y. And subject to the condition y is tends to 1, y is equal to 1 when x is equal to 0. So this equation, see here, this equation is linear equation, and the right hand side is interestingly 0. So this is homogeneous linear equation or linear homogeneous equation. So no problem whether it is linear or non-linear, or that is it is homogeneous or non-homogeneous. The process of solving of this kind of equation are the same for both homogeneous and non-homogeneous. So that this equation is rewritten here. So dy by dx is equal to log x to the power y is equal to 0, and this can be written as dy by dx plus y log x is equal to 0. So now you have to calculate the integrating factor. So integrating factor, so in this case px is equal to log x. So integrating factor is equal to e to the power log x dx. That is equal to, that is equal to, that can be find out from here. See here, log x dx using integration by parts. We finally obtain x log x minus x. So integrating factor is equal to e to the power x log x minus x. That can be written as e to the power log x to the power x into e to the power minus x, and you know that this can be written as x to the power x into e to the power minus x. Now multiplying this equation by this integrating factor, that is done here, and you know that this two term will give you, provide you ddx of y x to the power x to the power minus x, that is equal to 0, and from where you can write this is a constant, or y is equal to cx to the minus x e to the power x. This is the required solution. Now using the boundary condition, that was y is equal to 1 when x is equal to 0, just impose this boundary condition in this equation. 1 is equal to c into 1, that is c is equal to 1. So from here you finally get the solution as y is equal to c. C means here 1, so x to the minus x e to the power x. Another problem is that dy by dx plus 1 by x it is equal to e to the power y x by x square. So the right hand side also consists of uh, function of y. So you need to make this term free from the function of y, and to do this you can do one thing, that is divide both sides by e to the power y. That is here done here. So e to the power minus y dy by dx, then e to the minus y by x, that is equal to 1 by x square. Now it is yeah, it has the form of linear equation. Obviously it is non-homogeneous. So now substitute y to the minus y is e to the minus y as z, and from here you can calculate that e to the minus y dy by dx is dy by dx is equal to minus dz by dx. Now substitute this value in this equation, you obtain dz by dx plus z by x is equal to 1 by x square, and from here you can calculate the integrating factor, and that integrating factor will be 1 by x dx, that is here e to the minus log x, and that can be finally give you 1 by x, and then multiply this equation by 1 by x, that is the integrating factor that is here, and the first two term, that is this two term, will give d dx of z by x, and that is equal to minus 1 by x cube, and then just integrate both sides and you finally get e to the power minus y. Yeah, z is equal to, sorry, z is equal to 1 by 2x plus cx. Just go through these lines, no problem will be there. So from you know, and now you have to substitute the value of z, that is e to the minus y, that is equal to 1 by 2x plus cx, or from here you can write minus y is equal to log 1 by 2x plus cx, or y is equal to minus log 1 by 2x plus cx. This is the required solution. Another problem is here, see here, solve the differential equation dy by dx plus x sine 2y is equal to x cube cos square y. So right hand side also consists of a function of y. So this term should be made free of the function of y. And to do this, you have to divide both sides of this equation by cos square y. That is done here. 1 by cos square y dy by dx plus sine 2y by cos square y that is into x, that is equal to x cube. Or from here sec square y dy by dx plus you can write this sine 2y as 2 sine y cos y by cos square y x in x cube. From here sec square y dy by dx plus 2 from here tan y x cube. Now substitute tan y as z. So from here sec square y dy by dz is equal dy by dx is equal to dz by dx. Now substitute this value of sec square sec square y dy by dx into this equation. So from here dz by dx plus 2z into x plus that is equal to x cube. And integrating factor from here, p is here, this is linear, so no problem to solve this equation. So, and here p is equal to 2x, that is, so integrating factor will be e to the power integration 2x dx, that will provide you e to the power x square. So now multiply this equation, both sides of this equation, by the integrating factor, that is done here, e to the power x square dy by dx, then plus this is equal to this. So d dx of z e to the power x square is equal to x cube e to the power x square. Now integrating both sides of this equation, you have dd of z from here you can write d of z e to the power x square, that is equal to x cube e to the power x square dx. So the right hand side, now you have to calculate the value of the right hand side. So from the right hand side you can write this as x cube e to the power x square dx, that is equal to x square e to the power x square. You can write x cube e to the power x square dx. You can write it as x square e to the power x square into x dx. Now substitute these e to the power x substitute x square as u. So that is here 2x dx from here du, or x dx is equal to du by 2. So just substitute these values in this expression, that is I is equal to u, then e to the power in this here in this expression. X square means u, e to the power u, then du by 2, that is half u e to the power u du. Now you have to integrate these using the formula of integration by parts, that is done here. Finally just go through these some lines, and this will give you I is equal to half e to the power x square minus 1 plus c, after substituting the values of u. Okay, so from equation, so now you can find out from this equation, that is from this equation, this equation from where this was from this equation number 4. The left hand side will be z e to the power x square. So that is here z e to the power x square, and the right hand side is this. So that is here, or z is equal to half x square minus 1. This x square and this x square will cancel out, and this there will be e to the c minus x square. E to the minus x square, or tan y. You know that z was taken as tan y, so tan y is equal to this. So this is the required solution. And another problem is here. This is x square y divided by dz plus tan y is equal to x square. So this solving this problem is similar to that of the initial previous one. You need to just substitute tan y is equal to z and do it. After doing it, you will get this equation, the given equation as this, and after that you have to find out the value of integrating factor, that is done here. And after finding out the integrating factor, you multiply given equation, this equation, and go and proceed as it was done in the equation in the problem number 8. This is problem number 9 in the case of problem number 8, and you will finally get that tan y is equal to x squared by 3 plus a by x. So this is the recursive. So in this class we understand, or we know, or we learn how to solve a linear equation, whether it may be homogeneous or non-homogeneous. There is no problem, the process is the same, and in this case we have to find out first the integrating factor, and by the knowledge of integrating factor you can easily calculate or easily solve the linear homogeneous equation.